Welcome to the Explainer. So look, we are officially moving away from the era of pure prompt engineering and stepping into the highly complex world of context engineering. Today, we're unpacking a groundbreaking new benchmark that exposes exactly where our most powerful AI models are falling short in the real world. And more importantly, we're going to talk about how we can actually fix it. Right off the bat, we got to ask a pretty huge question. Why do supposedly smart AI models completely fail in the real world? It's kind of crazy, right? We've got these large language models today that can effortlessly pass bar exams and absolutely ace standardized tests, yet they are still causing documented hallucinations in high-stakes enterprise workflows. I mean, back in 2023, we saw some very real documented failures in claims automation. That proves pretty definitively that raw, generalized intelligence doesn't automatically translate to operational reliability.
Think about it like this. On one side, you've got general knowledge. This is your broad, pre-trained pattern matching. It's essentially a closed-book trivia test where the model is just relying entirely on what it memorized during its training phase. But on the other side, you have contextual grounding. This relies on specific, verified data that is absolutely required for high-stakes domains. It's way more like an open-book medical board exam where exact, verifiable facts matter so much more than just sounding confident.
All right, so here is our roadmap for today. We're going to start with the general knowledge illusion, look at the rise of context engineering, and then introduce CANDI-QA. After that, we'll break down how it works, check out the benchmark results, and finally, chart out the path forward to help you measure and fix production readiness. Okay, Section 1, the general knowledge illusion and why it's often just an illusion of capability in current language models. So here's the real kicker. Our standard evaluation metrics? They're totally leading us astray. General benchmarks are fantastic for testing broad knowledge retrieval, for sure, but they completely fail to test contextual grounding or user awareness. When you're operating in high-stakes environments, think medical diagnostics or financial advisory. An AI that relies solely on pre-trained pattern matching is a massive liability. The reality is, general knowledge metrics just do not correlate with domain reliability when you're dealing with critical data. Moving right along to Section 2, the rise of context engineering and a major shift in how developers are spending their time and resources. You know, Ken Exner, the Chief Product Officer over at Elastic, hit the nail on the head at the Elastic On Sydney conference back in 2026. He said, AI in production is fundamentally a data problem. If the model doesn't have the right context, it doesn't matter how powerful the model is. It won't produce the right answer. And that perfectly captures why early generative AI pilots, the ones that treated AI just like a simple chatbot problem, disappointed so many executives. Success depends way less on prompts and parameters and almost entirely on the quality of the data feeding the models. And that brings us to the new enterprise battleground, context engineering. So what is it? Well, it's essentially the process of delivering super relevant enterprise data across structured and unstructured sources like your PDFs, emails, Slack messages, and application logs directly to AI systems in real time. Instead of just tweaking prompts all day, developers are now architecting these complex pipelines where multiple agents have to collaborate to retrieve and assemble all this mixed data before the generation process even begins.
So how do we actually measure success here? Well, researchers dropped a rigorous new data set. Let's get into Section 3. Enter CANDI-QA, a brand new benchmark.
All right, let's look at the specs. CANDI-QA stands for Contextual Alignment for Niche Domains Question Answering. It was actually triggered directly by those 2023 claims automation failures we talked about earlier, and it officially launched with 5,000 expert-curated queries spanning 5 niche domains, with plans to expand well past 10,000. But what makes this benchmark truly revolutionary is that it treats context quality as the primary variable, instead of just obsessing over the model's underlying architecture.
Okay, Section 4. How CANDI-QA works. Let's pop the hood and look at the specific evaluation steps. The benchmark basically splits queries into 2 specific types to really test if a model can connect the dots across complex information. First up, we have information assistance questions. These are direct factual queries that require precise extraction right from the provided context. Simple enough, right? But second, and this is where it gets incredibly tough, are applied inference questions. These involve multi-hop reasoning tasks that demand situational inference to generate actual actionable insights. And they are unbelievably strict about this grounding. The rule is simple. Full credit is only granted when a model's citations precisely match the gold references. There is absolutely zero partial credit given for plausible sounding but unverified outputs. If a model hallucinates a beautifully written answer but cannot map it to a verifiable context segment at the token level, it gets a flat score of 0. No exceptions. So the million-dollar question: how did over 10 diverse language models, from tiny open-source deployments to massive state-of-the-art proprietary systems, actually perform on this test? Let's dive into Section 5, the benchmark results and LLM performance. Well, the results show a really consistent and, honestly, kind of alarming failure mode. Standard autoregressive decoding actually works adequately on those direct information assistance questions, as long as the provided context is squeaky clean. However, when we shift to applied inference, performance degrades sharply. When trying to execute that multi-hop reasoning, most evaluated models simply lose track of their source attribution. They output answers that might look internally consistent, but they become totally ungrounded from the external reality of the source material.
But here is a really fascinating takeaway that levels the playing field. This neutral finding tells us that the performance gap between massive proprietary systems and smaller open-source models actually narrows significantly when you decouple context retrieval from generation. What does that mean for us? It indicates that the core bottleneck isn't just about how many parameters a model has or the sheer scale of its training data. It's really about the model's architectural alignment with retrieval pipelines and strict citation validation.
All right, let's wrap this up with Section 6, the path forward, and figure out the exact next steps developers and researchers need to take.
Here are your immediate actionable takeaways for building trustworthy AI in high-stakes environments. First and foremost, we have got to stop validating specialized production workflows with general QA benchmarks. They just do not correlate with domain reliability. Secondly, if you're deploying models in medical, legal, or financial contexts, you absolutely must implement strict token-level citation validation directly into your CI/CD pipelines. Every single claim has to map to verified data. And finally, for the researchers tuning in, consider contributing to the expanding 10,000-query CANDI-QA dataset. It's going to help the whole industry reduce context drift.
The research paper also throws us a lifeline with a concrete architectural solution. You might want to audit your pipelines and consider adopting hybrid architectures like the MTSSNet baseline. It's this lightweight neurosymbolic framework that combines standard neural retrieval with explicit rule-based reasoning. By applying these symbolic constraints directly to neural outputs, it improves accuracy and trustworthiness without requiring you to massively scale up your model's parameters. It's a seriously efficient way to keep your AI strictly grounded. To close out this explainer, I want to leave you with one final provocative thought to evaluate your own enterprise deployments. Is your AI just matching patterns from its pre-training, or is it actually grounded in your reality? As we've seen today, in this new era of context engineering, sounding smart is simply no longer enough. Your systems have to mathematically prove their work. Thanks so much for joining me, and I highly recommend diving into the CANDI-QA research paper to test your own systems against this new standard.